Hello ladies and gentlemen, today we have Pre-Calc lesson 23. We're going to talk about the exponential function and sketching exponents. So the exponential function, okay, if we have an exponential function, people say things like that increases exponentially, means it gets bigger and bigger really fast or smaller and smaller really fast, okay? Now, what we're doing is our expressions are called powers, okay, and they come from an exponential equation, okay, where the base is a constant that is not 0 or 1. The reason we don't do 0 or 1 is because it would just be flat, right? And negatives are not the base. And the exponent is our variable. So let's just jump into an example. It looks something like this. Y equals 2 to the x. And we are going to graph this. Okay? Now, the best way that we know, or really the only way we know right now, is creating an XY table. So let's do that. So let's do -2, -1, 0, 1, 2. Let's start with the easiest. If I plug in 1, I get 2. 2 to the 1 is 2. If I plug in 2, I get 4. 2 squared is 4. And then we graph those. This is 2, 4, and 1, 2. Okay, now if I plug in 0, I get 1. Now that is an important trait here. Okay, all exponential function graphs go through 0, 1. Why is that true? Because everything raised to the 0 power is 1. All right, now let's plug in -1. So we have y equals 2 to the -1, which we know we can never have negative exponents, so we rewrite it as 1/2. So -1 gives me 1/2. Same thing for y equals 2 to the -2. I put it in my denominator, so 1 over 2 squared, which is 1/4. And I notice, okay, notice how my graph is not crossing the x-axis. The reason for that is, again, we cannot have any negative values for y. There's nothing I could plug in here for x to get a negative value for y. Y has to be positive. Even if we plug in a negative value for x, y is always positive. All right. Now, let's move on and talk about sketching exponentials. Okay. Now, as I just showed, they always go through 0, 1. Always, always, always. The other thing is they have a horizontal asymptote. Okay. Now, in the last graph, we noticed my horizontal asymptote was the x-axis, right? My graph did not cross it. It approached it, but it did not cross it, which is the definition we just learned of an asymptote. Okay? Now, if we have a whole number base versus a fractional base, two different things happen. Okay? So we're going to figure that out by doing two more examples. We're going to graph y equals 5 to the x, and we're going to graph y equals 1/4 to the x. Okay? So I'm going to create my xy chart for both. I typically always use these same values, -2, -1, 0, 1, and 2, because they are the easiest values for us to be able to work with. Now we know that for both of them 0 Our y value will be 1, because that's one of our definitions. Now, 5 to the 1 gives me 5. 5 squared gives me 25, right? And negative 1 and negative 2 give me the reciprocals, 1 over 5 and 1 over 25. Now, we know that if I do 1/4 to the 1, it gives me 1/4. Now, what if I do 1/4 squared? It gives me 1 squared over 4 squared. So I get 1 over 16. Well, what about if I have the opposite of negative 1? Right? Then this is 1 to the negative 1 over 4 to the negative 1, and I make everything positive, which gives me 4 to the 1 over 1 to the 1, gives me 4, which is the reciprocal. And 2 is going to be the reciprocal here. So now if we look at what happens with each of these graphs, we know they go through 0, 1. Okay, here when I have 1, I go through 5. And when I have 2, I go through 25, somewhere up here. Negative 1, I go through 1/5. And negative 2, I go through 1/25, giving me a graph very similar to the one we just did, just a little steeper. Now let's look over here. Again, I go through 0, 1. And I made a bad mistake. I didn't label my graph. Always label your graph. Now, if I look at negative 1, I go through 4. Negative 2, I go through 16, which is going to be about up here. If I plug in 1, I go through a 4th. And if I plug in 2, I go through a 16th, which gives me a graph that looks like this. Now notice both of these go through the point 0, 1. And both of them have the same horizontal asymptote, which is y equals 0. Right? This is my asymptote. They are approaching this line here, but never crossing it. But look at the difference. If I have a whole number base means my graph is exponential growth. Okay? Or it gets larger. If I have a fractional base, then I have what's called exponential decay. I get smaller. And that's true of all of our graphs, whether they have a whole base or a fractional base, they will always look about like this. Okay? Now, we are going to do more things with this, but right now we are not going to graph it in our calculators, so you need to be able to do these by hand. But for now, that is all for our lesson. Hope you have a great rest of your night.